Okay, this is example 1 on your yellow notes. Today we need to figure out the horizontal asymptote. It says over here, compare the degree of the numerator and the denominator. What does that mean? Well, the degree is the power. In the numerator up here, before I canceled anything out, this is the one I need to look at. What is the power of x? It doesn't have a power. So what does that mean the power is? So in the numerator, I'm not looking at the minus 2, I'm just looking at the x. I have x to the first power in the numerator. In the denominator, I'm not looking at the 3, I'm not looking at the 6, I'm only looking at the x. I have x to the first power. The x to the first power in the numerator, x to the first power in the denominator. Would you say that those are equal? Okay. Then look on the side of your paper, the left-hand side of your paper, and you will see this part of your notes. Do you see where it says number 3, horizontal asymptotes? Right here it tells you what to do if the numerator degree is equal to the denominator. That is case 3b. And it says y equals a over b. Where are you getting the a over the b? Well, back to this problem. This part right here. We have 1x on top, and we have 3x on the bottom. And what was going to happen to the x's? They will cancel out, and so the horizontal asymptote is at 1/3. Now, we're going to have to keep that chart handy because it's got all the rules for it. It'll take a while to learn those rules. Okay, we did the x-intercept. We did that yesterday. Today we have to do the y-intercept. This says solve f0. What does f of 0 mean? In place of x, put 0. So I'm going to, it doesn't matter whether you use the factored form or the form before you factored. It is usually a little bit easier if you use the original equation before you factored and canceled anything out. Doesn't matter. You can use either one. You'll get the same answer. And what this tells me is that in place of the x, I'm going to substitute in a 0. So what is 0 subtract 2? 3 times 0 plus 6. And what does that reduce to? Now, that is the best answer. But what is coming next is to put this on graph paper. Now, that's tomorrow. What are you better at graphing, decimals or fractions? Most people are better at decimals. So you can put this in fraction form, or you can put it in decimal form, whichever way is going to be easier for you to graph. Either way is correct. Now, do you notice that on your paper, this is highlighted with a darker color and your range is highlighted with a darker color? That's to alert you that they go together. The range is everything except for the horizontal asymptote, and we already had that one filled in from yesterday. Wait, that was a negative 1/3. I left out my negative sign. What this range is telling me is we go from negative infinity to the asymptote at negative 1/3. We stop at the asymptote, we skip over the asymptote, and the other part of the graph goes from negative 1/3 to infinity. That will become a little more clear when we actually put all the things on the graph. That's what comes tomorrow, is taking all these asymptotes, the x-intercepts, the y-intercepts, putting it all on the graph paper and seeing what the graph looks like. So next, on your beige colored paper, problem number 2, did there have a hole in this graph? Why was the word none written here? Do you know where the holes come from? We don't know? Did anything cancel out? So, see, that's why I'd ask this. Did anything cancel out? The answer there is no. Then there's not a hole in the graph. Okay, so what do we have for our vertical asymptotes from yesterday? Oh, I wrote it down the other way. We wrote it down with the -1 first yesterday. Does that matter? Okay, so what we're looking at today is the y parts, the horizontal asymptotes. So up here at the graph, before I canceled anything out, this is the part I'm looking at. Actually, not even the 2, just the x's. In the numerator, I have x without any power. In the denominator, I have x squared. So this one is less than x squared. X to the first power would be less than x to the second power. So I look over here on my chart. What does my chart tell me if the numerator degree is less than the denominator degree? Do we know our signs here? The sign, if it's pointing to the left, maybe we need to write this in. This is a less than sign. And so if the numerator degree is less than the denominator degree, this is going to be y equals 0. Yesterday we figured out the x-intercept. Today we need to figure out the y-intercept. This says solve f of 0. That means write the original equation down and in place of x, substitute in a 0. Well, what's 2 times 0 subtract 1? 2 times 0 is 0. This zeroes out, so I just have a subtract 1 on top. This zeroes out, this zeroes out, so I just have a minus 3 on the bottom. The minus signs cancel out. You can write this as a fraction or a decimal, whichever way is going to be easier for you to graph. The range is everything except the horizontal asymptote. In problem number 3, did anything cancel out? What canceled out? Where this part canceled out, that's where I got a hole in the graph. And the hole in the graph is a point. So a point has an x part and a y part. We're going to come back to this part right here in just a minute. But we're going to go ahead and do our horizontal asymptotes so we can show you how the chart works. On the numerator, there's the degree in the numerator and there's the degree in the denominator. I have an x squared on top and an x squared on bottom. I would say those would be equal. So, I go back to my chart. What does my chart say if they're equal? What says this A over B thing? Where does the A over B come from? In the numerator, it's 2x squared. In the denominator, it's just 1x squared. I don't care about all that's not all that's there, but that's all that's going to affect the asymptote. What's going to happen to my x squareds? They're going to cancel out, and so the asymptote is going to be at 2. How am I going to find my y-intercept? Write down the original equation, and then what? In place of x, put in a 0. That zeroes out, that zeroes out, that zeroes out. So what's left is a -2 over a -3. What's that equal to? 0.67 in decimal form. Now, we can't figure out our range yet because there's something else up here at the top we still have to figure out. This hole is a point on the graph. A point on the graph has an x value and a y value. So we need to figure out the y value. How? Okay. What is the part of the graph after you factored and canceled? After you factored and canceled, what's left? Is that what's left? So, what did I figure out for the whole? The x value is -1. So I'm going to figure out f of -1. How do I do that? In place, I'm going to write it over here so it's a little bit more readable. In place of the x, I'm going to substitute in a -1. Now, if you're not very good with your positive and negatives, put this numerator in your calculator all in one step with the parentheses to figure out what the numerator is equal to. Put the denominator in the calculator all in one step with the negative signs as written, and you get -4 over -4. What's that equal to? So the y part of my graph, which gives me the y part of my whole, that goes right up there. Now, this is a y value, so it affects the range. This is a y value, so it affects the range. So the range, down here at the bottom, the range is going to be -infinity to 1. Then there's going to be a piece in between 1 and 2. And then there's going to be a piece to infinity. That starts getting complicated. So, I did want to show you that it can be written in interval note form, but do you remember way back from the beginning of the year all the way back to August, interval notation is not the only form, is it? Did we have an inequality form? In inequality form, how did we express negative infinity to positive infinity? We didn't actually use inequality notation. We used the symbol R for all real numbers. So instead of writing it down this complicated way, we can say all real numbers except the whole and the asymptote. You like that way better? This is the y part of the whole. This is the horizontal asymptote. Interval notation, and even though it doesn't have an inequality sign, this is like inequality notation. You can write the answer in either form. I would assume most of you will choose the second form. Am I right? Okay. Problem number 4. So, was there a hole in problem number 4? Where was the hole? So if you solve, when you solve x minus 4 equals 0, that gives you the x part of the whole. We also have to figure out the y part of the whole. To figure out the y part of the whole, you look at the equation, the part that did not cancel out. You know where I got that? That's the part that did not cancel out. So, in place of the x, I am going to put this 4 right here that I figured out yesterday. I hope we can do that without a calculator. What's 4 plus 4? We figured out the vertical asymptote yesterday. We're going to figure out the horizontal asymptote at this time. To figure out the horizontal asymptote, you compare the degree of the numerator and the denominator. I have an x squared on top and an x to the first power on bottom. X squared is greater than x to the first power. What does my note say about that? And so you might want to write in here, if you don't remember your signs, this is the greater than sign. So it says there is none. And this one was none also. For the y-intercept, you go back. It's easier to go back to the original equation. You can use either the original equation or the one that had been canceled out. In place of the x, substitute in a 0. That's what f of 0 means. So we're going to have negative 16 divided by negative 4. What do we got? The range is going to be everything except the whole. When it's something pretty simple like this, you could probably go ahead and write that in interval notation. Or you can write all real numbers except 8. You can write it this way or you can write it that way. Either one is acceptable. Okay, so we done there? In problem number 5, we had a part that canceled out. The part that canceled out made a hole. If it's a hole, it's got an x value and a y value. So to find the y value, you look at the canceled out what's left after you canceled out the whole. In place of the x, is this getting too small? In place of the x, I'm going to substitute this 1 that I calculated yesterday. 4 times 1 on top, 1 plus 5 on bottom, that's going to be equal to 2/3. You can put it in 2/3 or you can put it in decimal form, whichever is easiest for you to graph, because what comes next is graphing. We figured out the vertical asymptote yesterday. For the horizontal asymptote, we'd compare the degree on top with the degree on bottom. What do we notice about that? They're the same, so we have 4x squared on top and 1x squared on bottom. And what's going to happen to my x squareds? And so this is going to be just 4. We did our x-intercept yesterday. What was the x-intercept? 0. And so to find our y-intercept, it's easier for the y-intercept to go back to the original equation. X squared plus 4x minus 5. And in place of the x, what am I going to put in place of x? Put a 0 in place of x. Uh-oh, what does that make the numerator? 4 times 0 squared minus 4 times 0. What's that equal to? What's that equal to? Now, once again, when you start having more than one whole or more than one asymptote, instead of writing in interval notation, you can write in the other notation. So it's all real numbers except the whole at 2/3 and the asymptote at 4. Wasn't that where the asymptote was? Note paper. Did problem number 1 have a whole? No. And so there was no whole. And this was at 5. Okay. So the reason I wanted to look at problem number 1 is it says compare the degree of the numerator and the denominator. There's not an x in the numerator. You see an x in the numerator? If there is not an x in the numerator, that's x to the 0 power. There's not one. Do we remember what anything raised to the 0 power is? Anything raised to the 0 power is 1. Not 0, not negative. Anything raised to the 0 power is equal to 1. Okay, what do we have in the denominator? The degree of the numerator is less than the degree of the denominator. So look over there on our note paper. What does that tell us? Okay, for those of you that were absent yesterday, solve the numerator. The numerator is 1. Can 1 equal 0? Is that possible? Not possible, and that is why there is no x-intercept. Okay, for the y-intercept. f of 0 equals 1 over 0 minus 5. Is that equal to minus 5? It's not. What's that equal to? The correct place to put the negative is out in front, not with the 5. And so this is negative 1/5. And so the range is going to be everything except the asymptote. You can write it this way, or you can write it this way. You don't have to write it both. You can write it one way or the other. You need to finish all 10 problems before you come to class tomorrow, because what are we going to do in class tomorrow? Graph.